Today we're going to be talking about some of the basic drawing functions of P5JS, and we're going to be talking about some of the basic shape creators, and then how we can manipulate those shapes by adding stroke weight, fill, and then we're going to be talking about this thing called push and pop, and we're going to be talking about a function called translate. But first things first, let's get situated with P5. So the first thing we see here is function setup. We have open and close parentheses, and then we have open and close curly brackets. And within the curly brackets, we have a function called create canvas, and then we've given it parameters 1000 and 1000. Now what this means is we're telling the computer to create a drawing surface, create a canvas, and you'll notice that the syntax is really similar to JavaScript, where we eliminate the spaces between words by capitalizing the first letter of the second word in the phrase, in the command. And then we've given the canvas the attribute of 1000 and 1000. Now what this means is 1000 pixels by 1000 pixels. Now 1000 pixels by 1000 pixels could mean 1000 pixels from this point up here. It could mean 1000 pixels from this point down here. It could mean 1000 pixels from this point down here. In P5 specifically, all of our beginning coordinates are going to start up in the top left corner. So this is our origin point. This is 0, 0. So from here, we're saying I want my canvas to be 1000 pixels wide by 1000 pixels tall. And we get a perfect square that's 1000 by 1000. Now, we've got the function draw. And within function draw is where we're going to create all of our lines, all of our shapes, and eventually all of our algorithmic form making, but that's going to be down the road in a bit. And I've given my canvas a background attribute. Now I call this function by saying background. I open my parentheses, and then I have a hexadecimal code. Now y'all should be familiar with these by now. But what I've done with this hexadecimal code in particular is I've put in single quotation marks around it. Now you can use regular RGB color values within the curly brackets. I'm sorry, within the parentheses, within the brackets. These are not parentheses. And it'll work just fine. So if I wanted to say 255, 255, 0, I'll get the same background because, as we all know, computers read value from 0 to 255. If I were to say 50, then I'm going to get green. But I prefer using the hexadecimal code. I think it's cleaner, and we can all go into Illustrator or Photoshop or a hexadecimal generator, and we can grab this code anytime we need it. So, now that we have our canvas set up and we have our color selected, we're going to start filling out some content within our canvas. And the first thing that we're going to start with is a line. So the way that we create a line is we write out the command. Our command is line, all lowercase. And then we open our brackets, and we first give it 2 coordinates, followed by another set of coordinates. Now these 2 coordinates refer to the beginning coordinates of our line. In this case, it refers to the top left corner of our canvas, which, as we all know, is coordinate 0, 0. So our line is going to start from the coordinate 0 on our x-axis, 0 on our y-axis. Then we're going to give it the coordinates 800, 800. And that's saying I want the end of my line to be 800 pixels out from the left on our x-axis and 800 pixels down from the top on our y-axis. And this is where we land. And because it's 0, 0, 800, 800, we get a perfectly 45-degree line. If I were to make this 1000, then we could make a line that perfectly bisects the entire canvas. Now, P5 is great in that spacing, what we call white space, doesn't matter in the syntax. I can break this down to the bottom line. I can put it all the way down here. It's still going to work. But Best practice tells us, and for clarity, it is always good to keep your code nice, neat, and clean. So in P5, there's no need for spaces. Take out the spaces. Get rid of any spaces that are unnecessary, and only include gaps in your vertical code if it's going to assist you in breaking down the code that you've created, if you've created different sections that you need to identify. Okay, so we've created a line, but I don't want to stop there. I want to start creating some basic shapes in P5. The first shape that we're going to look at is a rectangle. And the way that we call a rectangle is by the command rect, R-E-C-T, followed by open brackets. And then we again start off with the beginning coordinates of that top left corner of our rectangle. In this case, we're saying 0, 0, so we're going to start our rectangle at the origin of our canvas. And then we're saying 100, 100. And because we're starting our rectangle off at 0, 0, 100, 100 identifies specifically 100 pixels out from the left, 100 pixels down from the top. However, if I were to make this 100, 100, you'll notice that the origin of our, you'll notice that the corner that had the coordinates of 100, 100 did not stay in the spot of 100, 100 on our canvas. And that's because 100, 100 here identifies the width and the height of the rectangle based on its origin. So if I were to say 500, suddenly we're going to get a rectangle that is 100 pixels from the left of the canvas, 100 pixels from the top of the canvas, with a width of 500 pixels and a height of 100 pixels. I can change this to 500, and we get a square that's 500, 500. I'm going to change this back to 100, 100 for now. We're going to send our square back to the origin of our canvas. The next shape that we're going to take a look at is a circle. We identify a circle with the function name ellipse. And then again, we're identifying a couple of coordinates here. We have 500, 500 identified as our beginning coordinates. But you'll notice that our circle looks to be in the dead center of our canvas, as opposed to the rectangle identifying its origin coordinates as the top left corner. That's because ellipses have the center location as their origin point. So if I were to make this 600, you'll see that the center of the canvas, the center of the circle, is 600 pixels from the left side of our canvas and is 500 pixels down from the top. And then we have another two coordinates. And again, like our square, this identifies width and height of our circle. So if I were to say 500 pixels, then we make an incredibly wide oval. And if I were to say 20 pixels, then we're going to have an incredibly skinny, tall oval. Now, basic syntax of creating commands on P5 is always going to be the function name, the coordinates separated by commas, inside of brackets, and then a semicolon. This is how we're going to write all of our code in P5. So the next shape we're going to take a look at is a quad. Now the great thing about these shapes, circle, square, line, is you only really need to identify a couple parameters. You need to identify the beginning parameters and then the width and the height. So the origin parameters are where it's located on the canvas, and then the width and the height identify the actual physical parameters of our shape. But if we wanted to create something that wasn't, that didn't have linear angles on it, then we could create something like a quad. which gives us a lot more control in creating a shape which lies outside the rigid parameters of a square and a circle. So right here, I've created a shape that has 1, 2, 3, 4 sets of coordinates. Now again, our first set of coordinates are going to identify that top left corner of our shape. And so I've identified the top left corner at 100 by 100 pixels. That's going to put us right here, kissing the bottom right corner of our square, because we had made our rectangle 100 by 100 pixels wide and tall. Then I've said, okay, I want my second point, which is this point here, to be 200 pixels and 100 pixels tall. Now, this is referring to the coordinates on our canvas. So instead of saying I want my square to be 200 pixels wide, I'm saying I want this point to be 200 pixels from the left of the canvas, 100 pixels from the top of the canvas. And so that's what we have here. Then I have 200 pixels from the left, 200 pixels from the top. That gives us this point here. And then again, 100 pixels from the left, 200 pixels from the top. That gives us this point here. And then I can start making the shape a little bit more funky. I can say 100 pixels from the left. Sorry. I can say 50 pixels from the left. And so now we start to break this rigid mold of this square, and we realize that this shape can be manipulated to look like just about anything as long as it has 4 sides. If we say 0, then we're saying I want this point, the 4th point in our 8 coordinates, to be 0 pixels from the left side, 200 pixels from the top. So let's put that back at 100. Now let's take a look at making a triangle. So again, we've got more coordinates than our previous shapes had shown. We have 3 sets of coordinates. 1, 2, 3. And like the quad, what we're doing is we're identifying the 3 points on our triangle and where they're falling on our canvas. So the first point of our triangle, again, is 200, 200. We're saying I want the beginning point of our triangle to be 200 pixels from the left, 200 pixels from the top. We want the second point of our triangle to be 200 pixels from the left. 200 pixels from the top, 300 pixels from the left. Oh, I'm sorry. No, I had it right the first time. 200 pixels from the left, 300 pixels from the top. This is our second point here. And then our third point, we're identifying at 300 pixels from the left, 200 pixels from the top. That's this point here. And again, we can start to manipulate this. We can say 500 pixels, and now suddenly we have a triangle where its third point is 300 pixels from the left, 500 pixels from the top. Let's put that back to 200. And then our final shape that we're going to take a look at is the arc. And you'll notice that we have 4 parameters, and then pi and 2 pi. Now, you need to end the syntax of the arc. You need to end your final 2 coordinates with pi and 2 pi, or it will break. But the way that we define the parameters is, again, looking at where we want its origin to be. So we've said 800, 800. And the origin of the arc is going to be the center of the bottom vertice, or whatever the flat vertice is on our arc. So if you were to imagine this was a full circle, it would be the center of our circle. And that is still going to be the origin of our arc. Then we're going to say width and height. So we're not identifying where different parts of our arc are going to fall on the canvas except for the origin. We're saying I want our arc to be 100 pixels wide by 100 pixels tall. We can say I want my arc to be 600 pixels tall by 100 pixels wide. We can say I want it to be 50 pixels tall by 100 pixels wide. So that's our basic array of shape making, and that's a basic array of creating lines within the P5 canvas. Now you'll notice that our line is tucked behind our shapes, and that's because P5 will stack the shapes linearly as they fall vertically. So, as shapes come after one another, technically they will be stacked on top of the shapes which had been written before them. If we take our line, we cut it, and we place it at the bottom, suddenly our line is the top item within our canvas. Now let's start to talk about how we can alter these shapes in terms of color and stroke weight. So first thing we're going to do is add some stroke weight. I'm going to give everything a stroke weight of 10. Now, you'll notice again that in writing this command, instead of putting a space in between these two words, the first word remains all lowercase, and the first letter of the second word, weight, is capitalized. And then I've given ourselves a stroke weight of 10. And you'll notice that everything was affected by the stroke weight. This is because unless you identify another stroke weight within the vertical hierarchy of your shapes, the single command is going to affect everything. So if I come down here, and I have stroke weight 5 written above ellipse, quad, triangle, and arc, suddenly everything underneath this stroke weight callout has a stroke weight of 5 instead of having a stroke weight of 10. So let's take a look at that again. Everything has a stroke weight of 10. Everything is a stroke weight of 5. So now let's talk about color. We identify color within our shapes by the command of fill. And then again, I've used the hexadecimal code within fill to give us a color of green. And I could change this to blue. We could do a lighter blue. And again, you'll notice that everything is affected by this color because we haven't identified another fill beneath this fill. So everything underneath this fill is going to be affected by this fill. If I write fill red, everything underneath that fill, the ellipse, the quad, the triangle, the arc, is going to be red because I've called that out here. So we've talked about fill, we've talked about stroke weight. Let's talk about changing a shape from its origin rather than going back to its initial coordinates and changing them. Let's say I want my triangle and my arc to be moved 100 pixels farther to the right and 100 pixels farther from the top. Well, I can use the translate function. The translate function is written this way. Translate, all lowercase. And then I'm saying I want the triangle and the arc to be moved 100 pixels to the right, 100 pixels from the top. I can make it 200 pixels from the top. And you'll notice that only the triangle and the arc are being affected because they're the only two shapes that are under the translate function. Now, if I wanted to start manipulating the color, the stroke, and the position of my shapes, but I wanted to duplicate those shapes without having to write all of this information again, I can use the push and the pop functions. So what do I have? I have my triangle, which has suddenly appeared over here. And what I have here is I have a function of push, and this is saying I want everything underneath push to retain all of the stylistic values that I'm identifying in the certain shape that I'm calling out, except I want to change the fill. And so in this case, I have the same fill. But you'll notice, if I change it to green, only the shape that I have called out under push has changed to green. And I've also said I want my triangle to move 500 pixels from the left, 200 pixels from the top. So I'm changing the coordinates of my triangle here. But I've pushed everything to the right by 300 pixels. And then if I want that same triangle to move yet again, but retain its original styling, one second, I can use the pop function. And what the pop function does is it brings back the original styling that I had attributed to the triangle, or whatever shape I'm calling out. So in this case, I have the stroke weight of 10, and I have the fill of red. You'll notice that this version of the triangle I gave a fill of green. But again, it doesn't translate down to this version because I placed it under pop. Pop simply says, triangle, go find your original formal attributes. But then I've changed the location of the triangle yet again by 300 more pixels to the right. So this is a really nifty way to create simple iterations on a drawing sheet or on a canvas without having to recreate the code every single time. P5 is great at giving you little tools to generate pattern and shape without having to write out immense amounts of code. And it's one reason we love it so much.